Let's explore the longest increasing subsequence problem. You are given an array of numbers, and the goal is to find the longest subsequence where the elements are in strictly increasing order. A subsequence is a sequence that appears in the same relative order, but not necessarily consecutively. For example, in this case, the longest increasing subsequence is 0, 1, 2, and 3, which consists of 4 elements in total. Now let's dive into how we can efficiently solve this problem. To solve this problem, we first initialize a DP array of the same size as the input array, with all the values set to 1. This represents that at each index, there is at least one increasing subsequence, the element itself. Next, we run a loop with a pointer I, which iterates through the array. For each I, we compare it with all the elements before it using another pointer j. So for example, when I is at the first element, there are no elements before it, so we move to the next index. Now there is one element to the left of I, so we compare the current element in the input array with the previous element. If it's greater than the element at index j, it means that the sequence is increasing. In that case, we update the ith element in the DP array to the maximum of its current value, or the value at the index j in the DP array plus 1, as given in the formula. So here the new value becomes 2, so we update it. Now we move I to the next element and compare it with all previous elements. If none of the previous elements are smaller, no updates are needed. Otherwise, if an element at index j is smaller than the current element at I, we extend the subsequence and update the DP array accordingly. We repeat this process in a nested loop, ensuring that for each I, we check all the previous elements j and update the DP array where necessary. I will now pause the voiceover while the algorithm runs. Once the algorithm finishes, we simply return the maximum value in the DP array. This value represents the length of the longest increasing subsequence, which is 4 in this case. The actual sequence here is this one. Now our algorithm does not explicitly find the sequence itself, but only its length as required by the Leetcode problem. However, if you want to reconstruct the sequence, you can maintain an additional previous array to track the indices. And if you have understood the algorithm visually, the code is quite straightforward. Start with the function definition, taking the array as an input parameter. Define n, which is the length of the array, and initialize a DP array of the same size as the input array, setting all the elements to 1. Run a loop for n times to iterate through each element in the array. Inside this loop, run another nested loop up to I, ensuring we only compare elements before the current index. For each element before I, compare it with the ith element. If any previous element is smaller, update the DP array accordingly using this formula. Once the loop finishes, return the maximum value from the DP array, which represents the length of the longest increasing subsequence. Try coding this yourself and solving the problem on Leetcode.